Leaks can result in drafts and discomfort and are often well known to homeowners. In some cases, however, they're invisible and hard to find. This module presents more specific ways to spot air leaks in homes and provides some tips on how you can become a good leak detective. We'll discuss some visual inspection methods, some do-it-yourself tests, and some tools used by professionals, including blower doors and infrared images. Some good ways and places to look for leaks are any kind of opening in joints, specifically gaps around pipes, wires, foundation seals, and nail slots are very good places to look. This image, a dryer vent, is shown penetrating through a ceiling with a large gap, probably up into an attic space. This is a great place to add some sealants. We should also check if caulking and weather stripping indoors has been applied correctly and is still in good condition, making sure that there aren't any gaps or cracks. And another place to look is exterior caulk joints around the perimeter of windows and doors, and to make sure that that is in good shape and not cracking, and also storm doors and seals in doors to make sure they're operating and functioning well. This is a picture of the caulk joint around the perimeter of an exterior door. You can see it's starting to separate and deteriorate, and it would be a good time to look into replacing that. Another great place to look for leaks is in windows, and you should inspect them closely to see if they're operating well and performing the way they should. If you can rattle them, it means there's probably air leaks between the panes or around the frames. If you can see daylight around the perimeter of the window frame, then there's obviously some leaks. And you can also make sure that you check storm windows to see that they fit tightly and that they're not broken in any place, because a tight seal around them would also be important to stop air leakage. If you're having difficulty locating leaks, one thing you can do is conduct your own building pressurization test to assess the infiltration through cracks and make them easier to find. So the way to do this is first to turn off all the combustion appliances such as gas burning furnaces and water heaters on a very cool and windy day. Next, shut all windows and exterior doors and fireplace flues, and then turn on all the exhaust fans that you have in the house to blow air outside, such as bathroom fans, stove vents, or you can get a large window fan to suck air out of the house and into towards the outside. And after doing this, you can light an incense stick, any scent you want, and pass it around the edges of common leak sites. And if the smoke wavers or sucked out of the room, then you found a draft. If you don't like incense, you can also use a damp hand to locate leaks, because the drafts will also feel cool on the surface of your hand. Another method to detect leaks is to look for openings by shining a flashlight at night over potential gaps while a partner on the outside of the house looks for that. The larger cracks will show up as rays of light that are penetrating through the house. It's not a good way to detect small cracks, but the big ones do show up well. You can also shut a door or a window on a piece of paper, and if you can pull the paper out without tearing it, it's probably a fairly leaky connection and you're going to be losing energy there. A blower door test is a method that professional energy auditors use to assess the infiltration rates of a home. A blower door is a powerful fan that mounts in the frame of an exterior door, and the fan actually sucks air out of the house and lowers the air pressure inside the house. The higher outside pressure is then forced to flow through unsealed cracks and openings in the buildings. And auditors will likely use a smoke pencil to detect the exact location of different leaks. And in addition to that, the test can actually measure the infiltration rates of a home. The blower door itself consists of a frame and a flexible panel that fits in the doorway of different sizes, a variable speed fan, which is adjusted to reach a desired pressure level, a pressure gauge to measure the actual pressure difference on either side of the meter, and an airflow meter to assess the volume of airflow that passes through the blower door during the test. Some of the uses of a blower door test are to actually quantify the amount of leakage that exists in a home as an input to an energy modeling or analysis tool. You could also use a blower door test to see if a desired level of air tightness has been met through a retrofit or original construction. And you can document the air tightness level needed to qualify for some home labeling programs like Energy Star or Passive House. Let's take a look at how this actually works. So in this image, the meter connected to the blower door has two important numbers. The 50 indicates the inside to outside pressure level, measured in pascals, and in this case the fan has been adjusted to the right speed to create that desired target of 50, which is the standard number that most auditors use to do this test. The 467 is the volume of air passing through the blower door at this pressure level. So CFM 50 indicates that it's the CFM at 50 pascals. An important number that we calculate as a result of this is air changes at 50 pascals. So the number of air changes per minute would be calculated by the CFM at 50 divided by the volume of the home, and this would yield the number of air changes that would take place at 50 pascals. And that's a standard number we use to rate the tightness of homes. So taking a look at some of these numbers, in a relatively tight house, you might find a cubic feet per minute rate of 1,500 and an air change rate of about 1.5. In a moderately tight home, the CFM rate might be 1,500 to 2,500. And in a leaky home, you might find a CFM rate of 3,000 or higher and an air change rate of 3.5 or higher. Most new homes do have an air change rate of about 2.5. Older homes can vary from 3.5 up to 15, which is a very high number. The passive house standard is 0.6, which is very hard to achieve and indicates a house that is very tightly sealed up. Infrared cameras are powerful tools to spot heat loss in buildings, especially that comes from infiltration. They work best when there's at least a 30-degree temperature difference between the inside and the outside temperature of the house, and they use a color gradient to show hot, warm, and cold surfaces. In many cases, the most pronounced hot and cold spots are the result of air leaks. In this image, the warm surfaces go from yellow to red as they increase in the level of temperature on the surfaces. The white hot spots near the eave are likely an indicator of warm air escaping from the inside of the house. Another great feature of these images is that they're a very powerful tool to visualize heat loss. Most homeowners are real surprised when they see an infrared image of their home and they can actually visualize the heat that's escaping from their house.